So I thought I'd show you some actual meteorite samples that I have. I have a very small collection, well, relative to some people I know who have like hundreds of meteorite samples. Yes, you can actually buy meteorites. The cost depends upon how rare they are. Now, meteorites come in three broad classes, depending upon what they're made of. First, we have the iron meteorites because they're mostly made of, you got it, mostly made of iron, about 90% iron and 10% nickel. So here I have an iron meteorite. It's very heavy, very dense. You can see, hopefully, that it's starting to rust a little bit because that's what iron does. This is a piece of a large meteorite that fell in Arizona tens of thousands of years ago. It created a large hole in the ground called Meteor Crater, actually named wrong because it wasn't formed by a meteor, it was formed by a solid meteorite. Anyways, they never found the big chunk because it all just broke up into pieces. And it's estimated that if you could gather all the pieces and put them back together, it's about the size of a school bus, and it made a hole in the ground about 3/4 of a mile wide. I'll let that sink in for a little bit. You can figure out how much energy a meteorite has when it hits the ground. Now, a lot of times people will bring in slabs of iron and say, I found a meteorite. And all but one of those times it's been a, quote, meteor wrong. I know, bad joke. But how can you tell an iron meteorite from just a piece of iron left over from a factory from the 1800s? Well, one of the ways that you can definitively tell the difference between an iron meteorite and just a slag of pig iron is to do an acid test on it. What you do is you polish, you slice an end, and then you polish it with hydrofluoric acid. And if it's truly an iron meteorite, it will show a very distinctive crystalline pattern. This is called the Wittgenstein pattern, named after the gentleman who discovered it. And you only find this in iron meteorites. You do not find it in iron on the surface of the earth or iron that you would have in a manufacturing plant. All right? So those are iron meteorites. Now, we also have stony meteorites because they're made of, they're made out of stone. They're made out of rock. So here's one. This is an ordinary chondrite. That's the subclass. It basically feels like a rock. This is from Northwest Africa. And some stony meteorites are incredibly important because they are incredibly old and unprocessed. They have not changed at all since the formation of the solar system. They're the basic material out of which the planets formed. And this is how we figure out how old the solar system is. For example, if you want to know how long it's been since you cleaned out your refrigerator, you look in that bottom drawer, you know, the one you never open, and you find that piece of Domino's pizza from 3 months ago, and you know that it's been at least 3 months since you've cleaned out your refrigerator. Likewise, we take the oldest meteorites we can find, do radioactive dating on them, and we can figure out the age of the solar system. And the oldest meteorites are called Carbonaceouschondrites. The chondrules are little tiny globs of material. Here is a piece of a very famous carbonaceous chondrite. This is the piece of the Allende meteorite. It's by no means the whole meteorite. A lot of these were strewn across Mexico. And hopefully you can see those grayish chondrules. This is basic building block material that made the planets. This has been dated to about 4.5 billion with a B years old. Another famous carbonaceous chondrite fell over Australia, and I have a very tiny piece of that one because it's expensive. This is a piece of the Murchison meteorite, and the Murchison meteorite is famous because not only do we find water in it, but we find amino acids. Yes, amino acids, as in the basic building blocks of life. That doesn't mean that the meteorite had life on it. What that means is that the basic building blocks of life can form spontaneously in interstellar space. I'll let that sink in for a while too. Now, the third class of meteorites is a combination of stone and iron. What do you think those are called? Stony iron, yes. Here is a stony iron. It's a beautiful one. called a palisite. It's called a palisite because it is a piece of the same material that makes the asteroid Pallas in the asteroid belt. And you can see that the iron part has been shined, so it's a nice shiny silver color. And then you have this greenish brown stony mineral, and that's why it's called a stony iron. Now, when a large meteorite hits the ground, there's so much energy that it actually melts the rock, and melts the earth rock that forms the crater. And so some of this earth rock that's melted gets splashed up into the air, where it hardens as it falls back down, sort of like raining rock. Don't want to be there when it happens. Anyways, as this molten rock falls back to the ground, it makes these really cool shapes. So it can make a teardrop shape. It can make a sphere. It can make a button shape. They can also make dumbbells, but I don't have any samples of those. These are called Tectites. So these are not meteorites. These are pieces of earth rock that was melted in the energy of the impact, thrown up in the air, and then cooled on the way down. So meteorites are really cool to collect, but you should only buy them from a reputable dealer. Don't just buy them off of eBay.